All right, today we're going to take a deep dive, and I mean a really deep dive, into a tiny component that's at the heart of so many of our devices. We're going to deconstruct the XTX PN27G02B, a piece of NAND flash memory that, you'll see, is a small but mighty piece of engineering.
You know, it's something we take for granted, right? You snap a picture, turn your camera off, turn it back on, and boom, the picture's still there. How does that even work? Where does the data go? Well, the magic behind that is inside little chips, just like the one we're about to tear down.
So let's meet the star of our show, the PN27G02B. It's a 2 gigabit NAND flash memory chip, and the key term there is NAND flash, which is a type of non-volatile memory. In plain English, that just means it doesn't need power to remember things. We're going to crack open its official datasheet to figure out exactly what makes it tick.
So, here's our game plan. First, we're going to figure out what that crazy part number actually means. Then, we'll take a quick look at the company behind it, XTX. After that, we'll get into the really cool stuff, the core features, its performance specs, and finally, we'll see where this little chip shows up in the real world. Okay, let's get right into it. That name, PN27G02B, looks like a bunch of random letters and numbers, doesn't it? Well, it's not. It's basically a secret decoder ring that tells you a ton about the chip right from the get-go. Let's break it down. PN. That tells us the vendor, which is XTX. 27G is the tech. It's a 3-volt NAND flash chip. 02B tells us two things. Its capacity is 2 gigabits, and its organization is 𝐜𝐴, which is about how data gets moved around. And finally, BG tells us the physical package type. So just by reading the label, we've got a full profile. Pretty cool, right?
So we know that PN stands for XTX, but who are they? Let's take a quick look at the company that makes this thing. XTX Technology Limited isn't some giant corporation that makes everything. No, these guys specialize. They live and breathe this one specific thing, creating high-density, non-volatile memory. So this chip isn't just one product out of 1,000. It's right in their wheelhouse. It's what they do.
All right, now for the really good stuff. Let's pop the hood on this thing. What's going on inside? What are the key features that make this chip what it is?
So, as we said, it's NAND flash memory. This is the long-term memory for electronics. You know the RAM in your computer? The moment you cut the power, it forgets everything. NAND flash is the opposite. It holds on to data, which is exactly why it's used in things like SSDs and USB drives.
Now, this is a huge deal. This chip uses single-level cell, or SLC technology. Instead of trying to cram multiple bits of data into a single cell to save space, SLC keeps it simple. One cell stores one bit. And the payoff is massive. It's way faster, it uses less power, and, most importantly, it has incredible endurance. It can be written to and erased over and over again without wearing out.
And here's another piece of magic, built-in error-correcting code, or ECC. Look, data isn't always perfect. Tiny errors can just happen. ECC is like having a tiny, super-fast proofreader living inside the chip. It's constantly scanning for mistakes and fixing them on the fly, making sure your files don't get corrupted. And just how good is this proofreader? Well, for every chunk of data about the size of a paragraph of text, that's 528 bytes, this chip can find and fix up to 8 incorrect bits. That is a seriously powerful level of data insurance built right in. So we've got fast SLC technology and a built-in data proofreader. How does all that translate into actual performance and, trust? Let's look at the chip's blueprint and see the hard numbers. So here it is, the block diagram, basically the floor plan of the chip. You can see the I/O control, which is how it talks to the outside world. You've got the logic control, that's the brains of the operation, and then there's this massive grid on the right. That's the memory array itself. It's like a perfectly organized city for all your data.
And that data city isn't a mess. It's meticulously organized. Data is stored in pages, and then 64 of those pages get bundled together into a block. The filing cabinet analogy is perfect here. A page is a sheet of paper, and a block is the folder you keep it in. This strict structure is the key to how the chip reads, writes, and erases data so efficiently.
So just how fast is it? Well, check out these numbers. To program or write, data takes about 300 microseconds. Okay, that's fast. But to read it? Just 25 nanoseconds? That is ridiculously fast. Thousands of times faster, in fact. That's a direct result of that efficient SLC architecture we were talking about. Speed is great, but what about longevity? Well, this chip is designed to hold on to its data for at least 10 years.
That means you can store something on a device today and be confident that it'll still be perfectly readable a decade from now. That's what I call reliable.
Okay, let's tie this all together. We have a memory chip that's fast, super reliable, and built to last, with its own data protection system. So, where in the world would you actually use something like this?
Well, the datasheet is very clear about this chip's sweet spot. It's not for your laptop's hard drive. It's designed for devices where failure is not an option. We're talking about things like solid-state storage in industrial machines, dedicated voice recorders that have to capture every word, or the memory in a digital camera that needs to save a perfect shot instantly.
And it makes total sense, right? A camera needs that SLC speed to save a huge image file in a fraction of a second. A voice recorder needs that ECC data integrity to ensure there are no glitches in an important recording. This chip is the perfect blend of features for those specific jobs.
And hey, don't just take my word for it. This quote is pulled directly from the datasheet. The manufacturer themselves are telling you, this is what we built this for. It's a specialist component designed to be the rock-solid memory at the core of these kinds of devices.
Which leaves us with a pretty interesting question to think about. As these fundamental building blocks of technology, these memory chips, get even faster and more reliable, what kind of new devices are they going to make possible? What's the next big thing that will be built on a foundation of memory this trustworthy? It's exciting stuff. Thanks for geeking out on the details with me.